This homework solutions video is for Science and Mechanics, Unit 7 Hydraulics, Section 3 Hydraulic Systems. Number 1. A cylinder in a hydraulic clutch has a piston area of 1.24 square inches. If the cylinder must exert a force of 350 pounds to operate the clutch, what pressure is needed? In this problem, pressure is going to equal our force divided by the area over which it's applied. So we're told that the cylinder must exert a force of 350 pounds. So we'll write that on top, 350 pounds. And the area of the piston is 1.24 square inches. So the pressure that's needed in this problem is 282 pounds per square inch, or PSI. Number 2. A driver applies 80 pounds of force to a brake pedal with a 4.9 to 1 ratio. The master cylinder piston has a diameter of 0.920 inches. Part A asks us how many pounds of force are applied to the master cylinder piston. So in this problem, we're trying to figure out the output force. So our output force is equal to our input force multiplied by the mechanical advantage. So this equation should look familiar because we saw this in Chapter 5 when we were talking about simple machines. So in this problem, the output force is equal to our input force, which is the 80 pounds of force applied to the brake pedal, multiplied by the mechanical advantage. So the mechanical advantage will always be that ratio. So our brake pedal has a ratio of 4.9 to 1, so the mechanical advantage will be 4.9. Multiplying 80 pounds times the mechanical advantage of 4.9, we end up with an output force of 392 pounds. So 392 pounds of force are applied to the master cylinder piston. The next part asks us how much pressure is generated in the braking system. So again, just like problem number 1 in this unit showed us, pressure is equal to a force divided by the area over which it's applied. In this problem, we know what the force is. We found the force in part A. However, the area, we are not specifically told what it is. All that we're told is that the master cylinder piston up here has a diameter of 0.920 inches. So we have to figure out what the area of this piston is in order to calculate the pressure. So our diameter, and I'll just write it again down here, is equal to 0.920 inches. So we need to find the area of this piston. So a piston is a circle, so the area of a circle is pi multiplied by your diameter squared divided by 4. And again, we're told that our diameter is 0.920 inches, so we have to square that and then divide by 4. So when we take 0.920 squared multiplied by pi divided by 4, we should get an area of 0.665 square inches. So now this is the area that we can use to calculate the pressure. So again, the force was 392 pounds. The area, 0.665 square inches. So dividing those two numbers, we should end up with a pressure of approximately 589 pounds per square inch, or PSI. So 589 pounds of pressure are generated in the braking system. Part C then asks us how much force is produced by a 2.20 inch diameter caliper piston. So again, before we can try to calculate the force, because force is equal to pressure multiplied by the area, we need to calculate what that area is. So our area, and we'll do this calculation off to the side, is equal to, again, pi times the diameter squared divided by 4. So this time, we are looking at a 2.20 inch diameter caliper piston. So the diameter, 2.20 inches, and then we have to square that, divide by 4. We should get an area of approximately 3.80 square inches. So now we can go ahead and calculate the force. So the force is equal to the pressure, which we found in the previous part, because the pressure should be the same throughout this entire system. So the pressure throughout the system is 589 psi multiplied by the area of 3.80 square inches. We end up with a force that's produced by this piston of approximately 2,240 pounds. Part D then asks us how much force is produced by a 1.10 inch diameter rear wheel cylinder. So again, force is equal to pressure multiplied by the area. And again, we have to calculate the area because now we're looking at a 1.10 inch diameter cylinder. So again, our area calculation off to the side, pi times diameter squared divided by 4. And this time our diameter is 1.10 inches. So when we take 1.10, square that, multiplied by pi, divided by 4, we end up with an area of about 0.95 square inches. So now we can calculate the force by taking the pressure, again, from part B, that pressure is the same throughout the entire system, 589 psi, multiplied by our area of 0.95 square inches, we should get a force of approximately 560 pounds that's produced by this rear wheel cylinder.